Alrighty, hey, so we today are going, I believe, to talk about a couple of new words related to background noise, related to regression. We're going to look at residuals and error in prediction. The data that's on this screen, multitasking. The data that's on this team is data on this screen is some data about 8th grade point average and 9th grade point average. And I think the question is there a relationship between the two? How good of a relationship? How can we find that sort of things out? Okay, so we've got a bunch of data about everybody from Andy on down through Tony, alphabetical order. So what they get in 8th grade versus what they got in 9th grade. And we want to come up with some sort of a model. Okay. So if you recall from the last piece, when we're doing a regression equation, the calculator will do a lot of the work for you. Before I started the video, I took all that data, all of this data, and I popped it onto the calculator, put it into list 1 and list 2. I will now do a regression equation. So we'll get over to here, and we're doing a linear regression, number 4. And just for the sake of good order, we'll tell that our data is in list 1 and list 2. Reality-wise, you don't necessarily need to give it the list 1 and list 2. That's the default, but it's a good habit just to remember that you have to do something like that anyway. So, boom, we've got our linear regression. I didn't turn the diagnostics on like Ms. Welch told me to, but I do have an equation, and that's really all I need at this point. So the equation is, and let's see if I can remember as I switch over, y equals 0.576, y equals 0.576 x plus 1.33. Didn't want that. Plus 1.33. Okay, so this is my rate of change, 0.576. It means that every time my grade point goes up by a point, my 8th grade point goes up by a point, my 9th grade goes up by about half a point. That's what they're talking about. Okay, so we typically want to find out how good of a model this is, and there's a couple of things that we want to look at with the model. One is what happens, how does it work for people that weren't included in the data? So we have all these people from Andy on through Tony, but we don't have this guy Alex in our model. And Alex had a 2.6 in his. All right, so as I was saying a brief second ago, Ms. Welch just came in to run the printer. So we get this guy Alex in 8th grade, get a 2.6 GPA. And we're trying to figure out, well, what does this model say that he would have in 9th grade? So X is his 8th grade, and Y is his 9th grade. So we could just do Y equals 0.576 times 2.6, and then add 1.33 to it. Okay? And we can do the calculations on that. So I guess we'll have to kind of multitask here. 0.576. Actually, I'm going to do a little sneaky thing here. I'm going to go to, since I don't have this in the equation, all right, I'm going to do a couple of sneaky things on this. I'm going to first clear that out of here. I'm going to get that equation in. This is just extra bonus stuff for you. I can show you how to do it if you want to. I'm going to get that regression equation onto the calculator. There it is. Okay, and then back on my home screen, I'm going to evaluate, and I'll do that with vars. Over to yvars, and then function, and this gets me to y1. Okay, so I want to know the value of my equation when x is equal to 2.6. Okay, so I'm just going to do the y1 of 2.6. Okay, remember function notation? Sort of just doing function notation on the calculator. When I put this into the calculator, I always point to the little screen for some reason. When I put that into the calculator, it's just going to do, plug 2.6 into the equation and give me an answer. It's a whole lot faster. Okay? So I end up with his grade should have been a 2.83. Okay, that's what this model predicted. Alex got a 2.6, and he ends up with a 2.83 based on the model. Okay? Basically what we're doing is we say, okay, Alex got a 2.6, which is about there. We scoot up to the line. we scoot over and it gets to exactly 2.83. Let's see if we can do that with some sort of an arrow thing to make it look okay. 2.6 is about there, up to the line, and then straight over, and that's exactly 2.83 where you see it, okay? So the model predicted that. Turns out Alex was a house on fire in his 9th grade year, and he ended up with a 3.3. So what we want to know is what's the difference between his grade and the predicted value, okay? So what we want to find out is the difference between the predicted and the actual, okay? Predicted minus the actual. So we predicted that old Alex was going to end up with a 2.83. Okay. He actually got a 3.3. And so we just do 2.83 minus 3.3, which is going to be about negative 0.53. Okay. I'll probably make sure that's accurate. Let me go to the calculator. It's awful that I don't know. 2.83 minus 3.3. I'd rather make sure. How about negative 0.47? That's even much better. What was I thinking? Negative 0.47. Erase that. Destroy the evidence. Okay, back to the pen. Negative 0.47. Okay, so that is what's called error in prediction. Okay, and the reason it's error in prediction is because Alex was not in the original data. Okay, so Alex was not part of our original data set. It's not in the original data. Okay, so that's what makes it error in prediction. We just take the predicted value, the actual value, and so the model was off by about 0.47. It predicted that he would get 0.47 less than he actually ended up getting, which is pretty significant. That's, you know, the difference between a B plus and pretty much an A is a 3.3, like kind of a high A minus. So Alex stepped it up in that game. Okay, so error in prediction. We use the regression equation. We figure out what's predicted. We use the data and go from there. Okay. The other side, which is what the title of this video is about, is called residuals. Okay, and we're going to look at Monica, and Monica was in our original data. So this is Monica's 8th grade, and this is Monica's 9th grade over here. So we're looking at those two numbers. So what value does the model predict for Monica? So we've got my y equation. So I'm just going to do the y1. I'm going to do it the sneaky way of 2.9. So this would be what's predicted. If you don't want to do it that way, you can just go to there we go. All right. So for Monica, I did a little fancy stuff there. She had a 2.9, right? She had a 2.9. So we're just doing the y1 of 2.9. Just going to plug 2.9 into the equation, but I'm going to let the machine do it for me. So it predicts that Monica has a 3.0, 3.004 or something like that. Okay? So it predicts that. It turns out that Monica actually got a 3.5. So what's the difference between the predicted value and the actual value? So the predicted value was 3. The actual value was 3.5. I can do this one in my head, I'm pretty sure. Negative 0.5. Okay? So it would seem like we just did the exact same calculation, right? Shaking your head? Are you agreeing with me? It turns out we did do the exact same calculation. However, we're not going to call it error in prediction this time. This time it's called residual. Okay, and the reason it's called residual is because, in this case, Monica was a part of the original data. So she's in that table. If we go back to the very beginning, Monica's in the table. So she was part of the piece that gave the model to us. Okay, so we can look right here to the red dot. That's Monica. Okay, if we want to find out Monica's residual, we can actually see her residual. That's the length of this line right here. Okay, how far is she from predicted? She's half away. Okay, so that little point, that little thing right there, needs some color. Okay, that's called the residual. Residual. Got it. Okay? We can physically see it because Monica's part of the data. This is all the scatter plot of all those people back on the first page. Monica's one of them. We can see how far off it was. For Alex, he wasn't part one. He doesn't have a dot here. So we're just predicting based on somebody else coming into the model how good it is. Okay? So let's summarize. Error in prediction versus residual. How are they alike? How are they different? Okay? Well, we find them the same way. We do the predicted value minus the actual value. Okay, so either way, calculation's the same. Find out what's use the model to find out what's predicted, subtract what we actually observe, what actually happened. Okay, error in prediction. Okay, trying to write subject. Subject was not in the data that made the model. On this side, subject was in the data that made the model. Okay? So that's really the difference. If we're actually creating a model, we want to have the total like residual be as small as possible. We want our line to be as close to as many of these points as we possibly can have it. And when your calculator does that really quick thing, when it calculates the, oops, where is it? It's down here. When it calculates this, comes up with the equation, this y equals equation, it goes through all that calculations and it ensures that the line is the best possible one that there could be, that all my residuals are the smallest possible possibility that they can be. Okay? So Venn diagram. Error in prediction, not part of the deal. Okay? Residual, part of the original deal. Either way, we do predicted minus actual. That tells me the thing, tells me same basic information. What we call it depends on the data itself. All right, it's a blank screen, so we are done with this one here. Appreciate you watching. Appreciate you tuning in. Hope you learned something, and I guess we'll see you tomorrow. Thanks a lot.